We're partnering with TriMech to demonstrate SolidCAM, which runs completely inside SolidWorks and is a different program compared to SolidWorks CAM. By providing videos on both software solutions, our team aims to share the ability to leverage model-based definition and digital thread methodologies, regardless of the solution your company has already invested in.
Hi, I'm Nasir Mannan, Principal Engineer for the Connecticut Center for Advanced Technology. Joining us today, we have Dave Matuszek from TriMech, an expert CNC programmer. He has over 3 decades of experience in the field. Today, he's going to be walking us through how we can really leverage model-based definition in a product called SolidCAM. Dave?
Thank you for having me here, Nasir. Like Nasir mentioned, I'm going to be using SolidCAM. It's a product that TriMech is very happy to have become a reseller of in the last year. And what it is a CAM product that runs completely inside of SolidWorks. And the advantage of this for us here is I can see all my model-based definitions here in front of me in order to create my toolpaths. So one thing you see here, this is a file that you sent me, and it's got some really interesting details on it when you go through the MBD. For example, these 2 pockets look alike, but they have very different tolerancing on them. Some places have very open tolerances. Some places, like here, where I have a hole call out, it's a very tight true position. So between all of this here, I had to do a lot of different techniques in order to program it, but a powerful CAM tool like SolidCAM allowed me to do that. And let me just show you what my final goal here is going to be, is I'm going to use SolidCAM's patented iMachining to rough this out, which is an adaptive toolpath you'll see more about, and then some standard 2D toolpaths to cut through to a certain point, and then some cool, interesting drilling functionality and some toolpathing functionality to bring everything to within tolerance. So we will we'll get through that as we go here. So let me open up a part that I've already prepped in advance. I've already done my stock setup on, and I've already put my work coordinate system on, and we'll just start toolpathing it using some of the SolidCAM technologies. So you can see here we have the blank file with no toolpaths in it, just the basic setup done. And I'm going to use one of SolidCAM's patented technologies in order to rough out the bulk of this material. And what they call iMachining is an adaptive toolpath that's going to take into account lots of different things. So let's take a look here. I'm going to come in and do 3D machining, even though this is a prismatic model, because I have an option here called 3D prismatic. And I'm going to pick 2 tools. And the 2 tools I'm going to pick, I'm going to rough out the bulk of this material with a 1/2" tool, and then rough out the remaining material with a 1/4" tool. And I'm doing this all in the same toolpath. And I'm actually confident enough the way this is set up to just start calculating this right now. So it's going to take into account how many flutes I have on the tool, the material removal rate, the cutter material, the material that I'm cutting, all automatically.
Oh, wow.
So I don't have to set any other parameters. It's just going to do the rest for me.
Oh, that's a big time saving. So that database comes with SolidCAM.
Correct.
Oh, great.
It's all built in.
Also, what I'm noticing here is that what would otherwise have been a kind of a 3D roughing operation followed by a rest machining, all you have to do was select the 2 tools and it does that for you.
Yes, I set up the strategy in advance. So what we can actually see here, rather than sitting through the simulation here, what I'm going to do is turn on my automatically updating stock model, which is a feature I really love. And you can see here that this first toolpath, that 1/2" tool, could rough out everything but really in between here. So what I did is it came in with just that 1/4" tool and removed the rest of the material. And you can see how it went into some of the corners where that 1/2" tool didn't fit. So that really brought most of my part to within size. I'm within 20 thousandths everywhere right now. So now let's start adding on things to finish this model. So what I'm going to do first is I have a real simple slot here. And the tolerance on that is ±10. That's really open. I like to start with what's easy. So I'm going to come in here and I'm going to do a pocket operation. So I just pick that face. That's the face I want to cut. And because I picked the face on the model, it's going to know a lot about this already. So I'm going to use my 1/4" tool. It's a 1/2" wide slot. It already knew how deep to go. It knows the top of the model is. But I've already roughed that size. So I'm going to say I only want to do my wall and floor finishing at the total depth. And I'm going to hit my calculate button here. Another neat feature I really like about SolidCAM, I can check this right here in this operation. So I'm going to come down here and hit simulate.
Okay.
And without exiting the toolpath or creating any other stock models, that is where my stock is at that point in the toolpath.
Yeah.
And I can come down here now and just simulate that. And it's also in my simulation here, as you can see, it's stock aware. So it knows what's green is the size, what's blue is oversized. So I can see where I have more material I want to remove. Another place I might come here is use a toolpath to face off these tops here. So I'm actually going to save and copy. Let's just copy that operation. So I don't have to change much. The only thing I got to change is what I'm doing differently. So in this case here, I'm going to come in here and delete this face. And I'm going to come in and say, hey, I want to cut these faces. So you can see I've cut right there.
Yep.
And I'm going to save and calculate that because it should have updated my levels for me automatically with the new operation and the new geometry. So that operation now will come in and hit the tops of those islands for me.
So it uses the CAD geometry to automatically set up your levels.
Correct. And I'm going to use the same technology to finish these slots in here. Let's take a look at our tolerance. And the other nice thing here, I can actually just double click here and have my full screen back. And these slots are called out +2, minus nothing. So I'm going to do my save and copy. And I'm going to change my geometry to match what I want to cut now, but I'm going to make 2 other changes. Under my technology window here, for my cut +2 minus nothing, the mean of that dimension isn't right on the geometry. It's going to be minus 1/1000. Plus 1,000. Plus 1,000. I am sorry. So I'm going to go here and I'm going to add a wall offset here of 1,000. So that'll add that in right in the middle. So there we go. We are completed those 2 toleranced areas right there.
Great. So instead of having to go in and modify the surface or do a surface offset off the CAD,
I can change it right in the operation. Correct. Now, where I found here kind of the most interesting detail we have here is 2 pockets that look exactly alike. And if you were to just give me a solid model with no MBD on it, and the blueprint has coffee spilled on it, or it's lost, or I have the wrong rev, I might not know these pockets are very different. This pocket here has a profile tolerance of 10 thousandths that I can see, which is relatively open in modern manufacturing. And the width of the pocket is +2, -3. So I can be a little more open with it. I have an extra chance to be able to remachine that if I need to. The other pocket here is a profile tolerance of 5 thousandths, which is much tighter. And also, in the top, right here, we can see that that has a different tolerance on it. That's +3, -1, where this one's +2, -3. So I'm going to handle these differently.
Okay.
I'm going to use the same toolpath, but I'm going to use different settings. So I'm going to come in and go to a profile cut. And I'm going to say to it that I want to cut this profile down here. And I'm going to use that same 1/4" tool that I used on the other operations. And I have a decision to make. Some people would like to just do it all in their compensation in the machine offsets. I want to do it here in the software though. So what I'm going to do here is I'm going to tell it a value. So I have +2 -1. So again, a thou I'll put in there. And I'll save and calculate that. And we'll see our cut right in here. Now the next thing I'm going to do is I'm going to copy that again. And this other pocket is going to be a little bit different. So our geometry is obviously going to be the other pocket, but because of that tighter profile tolerance, I want to change how I'm going to cut this. So for example, I might take 2 finish passes for that tighter tolerance. That way I can account for the spring of the tool, any feedback. And that was a +3 -1. So I'm going to set this to say 2 thousandths in this case. And I'll calculate this. And we're good. We have both pockets cut.
So here you're really able to look at the 3D file, see the tolerance requirement that a particular feature has to be made to, and then you can define or come up with your strategy right away without having to ever leave the 3D environment.
Correct. So, and actually, let's take a look at a 3D toolpath here. I have 2 identical surfaces with 2 different surface finish callouts. A 16 finish and a 64 finish. And on the surface, if I didn't know that was there, I might cut these the same way. But one of 2 things could happen. Either I am too open with my step over and have a much rough finish on both of them, or I'm too fine and I waste a lot of time cutting the 16 finish when I didn't need that sort of surface finish here. So let's take a look how I might handle that. So I'm going to come in and do one of my 3D toolpaths. And I'm going to go to this HSS, which stands for high-speed machining. And for my geometry here, I'm going to just pick the surface that I want to cut. And I might actually change my strategy here to be parallel to a curve. And I'm just going to cut this curve right here. So it's going to take this shape and kind of project it down that surface. And it's a 16 finish. So what I'm going to do when I pick my tool is I'm going to pick my ball end mill. And here under my toolpath parameters, I have a step over settings. And one of the things is a scallop height. So different scallop heights at different materials and different horsepowers, different work holding will create different finishes. But once you calculate all that out and see how that works for you in your facility with your machine and your tooling, you get to the point where you can make a note of it in yourself that a 1/10 scallop height will give me this finish, a 1/1000 scallop height will give me another finish. So I might exaggerate this a little bit here, but I'm going to say that my scallop height here is 1/1000th of an inch.
So that's really, that particular parameter is really what's driving or can be linked to the surface finish.
Correct. And that is one thing about SolidCAM, it's lots and lots of pictures in it. So if I don't know what scallop height is, it's showing me when I click in the box what that scallop height is. So if you have a ball end mill and you cut the ball, you have that scallop in the middle. So I set that to 10 thousandths, and I'm going to calculate this. And very quickly, I have that operation. And if we verify it very quickly here, we can see that tool come in and cut that out. And it looks a little faceted here. I mean, there's graphics involved, but wait till you see what happens when I tighten that up. So what I'm going to come in here next and do is I'm just going to copy that again, because I'm only going to change a couple things. My geometry for one, so I'm going to come here and say I want to cut that along that curve. Then, under my technology pad, my tool tech parameter page, I'm going to set that to a 1/10.
Okay.
So now that it's set to a 10,000th of an inch and I calculate that, you can notice it takes a little bit longer to calculate. It's got a little more to think about. But we will come in and we will verify this. a little bit of a longer cut because it's a finer step over, more cuts to make. When it's done cutting, we'll actually be able to visually see how much cleaner that's going to look than the previous one we did. Well, let's take a look at some other things here. I have, these chamfers are called out. They're all pretty open tolerances. They're all plus minus 10, plus minus 20. There are plus minus, so I can make them right to the mean. But their diameters are called out. So you can see here in my top view where some of these counterbores are called out. So it's plus minus 20, and it's a 190 diameter. And I'm going to trust this data over anything in the solid. So what I'll do here is I'm going to come in and I'll do a drilling operation. And for my geometry, I'm just going to pick those surfaces. So I found the centers of all the holes. And I'll pick a spot drill. It's a 90-degree counterbore. I might as well use a 1/2-inch spot drill and be able to spot drill and counterbore those at the same time. But I'm going to set my drill depth to be the top here. But then I'm going to set this to a specified diameter. I want to cut to that tip. The tool is 190 in diameter. And again, I can check this to my model. I'll just hit play in here and simulate that. And I should see about green here. So that's good. That gives me that visual feedback. The next thing I'm going to do is I will come in and maybe drill these holes. And again, I have the call out over here for what size hole they need to be and how deep they need to be, but I can grab that right from the model. So again, I can reselect that geometry or do a save and copy because it's the same points. And grab the correct drill. So in this case, I'm going to grab a drill out of my library. So I know by looking out here that that diameter is 160. I'll go to a pre-built library. I'll go to this general library, and I'm going to search for drills. I have lots of different ways to filter this, but I just want to see drills, and I'll scroll down here until I find something that's 160 in diameter, 161 close enough because there's enough tolerance on there to use the number 20 drill. So you can see there I had a built-in tool library. And I'm going to tell it that my depth now is going to be down, watch this, I'm going to go, rather than trying to pick that tip, I'll pick right here on the shoulder, and I want to go to the full diameter at that depth. So there we go, that's the size, and again I can simulate that right from inside here to make sure that that's the cut that I expected to see.
What's really nice about this is that, because as you described before, there's a lot of attributes associated with the tool in terms of its recommended kind of feeds and speeds and depth of cut and all, that you don't have to set those up. You just simply select the geometry and you select the tool and it seems to calculate all for you.
Exactly. So for example, even pick the tool cycle. I can define a tool to say this is a tool we pack drill with, this is a tool that we do a standard tool cycle with, feed down, wrap it out. I can tell it that it's a tap. If it's a tap, it's going to set the speeds and feeds into the rigid tapping automatically for me when I do that.
Yeah, I can see that as being a huge time savings, because otherwise you'd be opening up your machining book and looking at the speeds and feeds to use. And the other thing I want to point out here too, because I mentioned initially how this is stock feedback as I simulate. You notice that this is yellow. Because I picked a tool that was slightly bigger. Not a lot bigger, but slightly bigger. So I expected to see that yellow. That's good. If I didn't expect to see yellow, then I have to ask myself a question, what's going on? Same here, you can see that I finished these walls, but I forgot to finish the floors.
So I could come in afterwards and do another operation to do that if I needed to.
Yeah.
Another thing here I can pull right off the model is let's finish this wall, and then we'll do the chamfer.
Okay.
So these walls have a 118 radius on them. And the easiest way for me to finish this would be when I finish this, after I finish this floor, to come in and do a contour pass around it. But I might as well finish this floor and this floor
At the same time.
at the same time. So I'm gonna go to pocket. And I'm gonna pick for my faces here and here. I pick a larger tool because it's a larger area to pick out.
Yep.
And that half-inch tool cut everything, but you remember here that half-inch tool didn't fit right in there.
Yeah.
Well, let's see what happens when we finish those. Maybe there's enough flat on the floor, and if not, we can come in with a remachining operation afterwards.
Okay.
So what I'm going to do next is I'll come in here and I'm going to do a profile operation. I'll start my cut right over here. So my tool will start on that corner. And I already have in here a tool with a 118 radius on it.
Oh, okay. Yep.
And I'm just going to tell it that that depth is right there. And when I cut that, that will bring that to size. And I did check, even though there's not a call out, I made sure that all those radiuses were the same.
Okay. Yep.
So again, because I have that model there in front of me, even though there was no MBD tied to that radius, I was able to just go in and measure the detail on the model. So again, I'm just going to do that, my favorite thing, which is a save and copy. And I'm going to pick some different geometry now, because these are all going to be at the same depth also. So we will grab there, 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 and there. And we'll set our depth now. Again, just picking on the face. And let's see how we did between those two areas. So that looks good. It looks like I don't need to do another operation to clean up in between there. And I'll do one more operation for you because everything else is just repetitive, me drilling holes and checking things again and again. I will just I'll use that spot drill to cut the chamfer.
Okay.
So again, I'll use just a regular profile toolpath to do that. And I'm going to pick this edge of the chamfer, but it's an open area on the end here. So I'm going to pick right there. And that chamfer is called out in the MBD. I did look at it. It's plus minus 20. So plus minus 20 is not something I tend to worry about in modern machining. I'll just run right down the center there. And it'll take that model right off the chamfer. And bring that right to size.
Nice.
So there you can see just a real basic overview of how I use MBD in SolidCAM and the advantages of being inside of SolidWorks in order to machine this.
That's great. Thank you so much for walking us through that. I can really see the value here in that you're using the native PMI. You're able to see all the tolerances that are associated with each of the features so that you can make the right strategy judgment. And you have the ability to adjust for the tolerance range so that you're machining to the mean right within the operation dialog. It just saves you so much time.
Correct.
You don't have to go in and look at.
And it is customizable to your own situation.
That's great.
So it has you'll need the horsepower of your machine and styles of tooling you have, but it's fully customizable.
Awesome.
And you can always overwrite it later.
Well, that's great. So you can save your own company's kind of proprietary ways of doing things and machining parts. That's excellent. Thank you so much for walking us through that. Yeah, appreciate that. I'm Nasir Mannan. Thanks for watching.